Cleaning messy ISV data is like solving a puzzle. Each row is a piece that doesn't quite fit. Diving into Python to fix these errors. Look at those red markers. I need to identify missing values and correct formatting. It's all about transforming chaos into clarity. With every line of code, I'm not just fixing data, I'm unlocking insights. It's a challenge, but when I finally see that clean output, it's pure satisfaction. Let's get this data in shape.
Every data scientist get that satisfaction after cleaning a messy data. Now let's look at this data here. This data is messy because there are some things missing. Just follow my cursor here. If you look at this under the law here, we have a missing data. We also have like this particular data. Now we have age. On this particular age, this is a student database. On this student database, we have a 6 years old student in a university, on a university setting. And we look at this, we have 1000, we have 1000 of age, 80. So with this data given here, it look like there are some age which are not supposed to be here, like this 6, 80, 1000 is not supposed to be here. And we look at the department, there are some missing on the department role column. There are missing GPA. Our GPA, we know that in a university setting, the maximum GPA should be 5, but we are having 10 here. We also have -4 here. We have 20 here, and we have 7, and we have -2. And if our task here is to inspect this data, then we clean this data. So let's go. We are going to be using Python in cleaning this particular data. So let's go to our Python. First of all, you need to save that particular data file into the same folder where you are working. So whatever we are working here, then we are going to save this particular record. So on a particular folder. So your folder, that same folder should be the same. Like if you look at this, if you show my cursor here, I have underscore database CSV file. And if you look at it, if you open it, this is everything we have there. This particular file is saved in the same folder. So that means our student database is saved in that particular folder. So therefore, Python can call it whatever that is here in this particular folder, whatever file that is here, the Python will be able to call it. So now let's go back to our Python. Remember, this is our messy data. This is our messy data. So we want to try to clean this particular data. So the first thing we need to do here is that we import our library. The first thing we need to import, we import our library, which is import Pandas as PD. So when you import that, we were able to read this particular file, and we read it as pd.read_csv. Then we put our student database, the file, inside with a single colon. Now when we do that, if you print it, we can print this particular file. Let's assume we want to print this particular file. If we print it, when we print our record, this is what we get. We're going to get as messy as it was. We're going to print here. We have our NaN here, which is, it means it's empty. Here is also empty. So this is what we can get. So for first, we need to inspect our data. So this is the first stage, is for us to inspect the data. And how do you inspect your data? If it's for easy inspecting of data, you can just print and the describe. Let's use describe method dot print student record. Okay, now look at this. We on this describe, what describe is trying to tell us is trying to tell us everything about our data. Now at this point here, for the age, the mean age is 45. Meanwhile, the age is supposed to range between 17 or 16 to 25 and 25, or at most 30. But here we are having 45. If you look at the GPA, someone got 3,333 for GPA, which the maximum is supposed to be 5. And the age here, we have somebody which is 1,000 of age, 1,000 years. which we know is not supposed to. So all these ad flyers we are getting, all these we are getting is ad flyers which we are supposed to clean. That means these particular data actually really need some cleaning. So now on it again, we can also we are trying to see, we are still inspecting our data. We can check what is the shape. We run that, we have here, if you look at this, we have here where my cursor is hovering, we have here 49 rows, 8 columns. So that is what we are working with. So therefore, now before we move further, let's also check how many missing rows and data are we having, so that if it is not that much, we can drop them. If it is much, then we can fill them. So let's see how many missing rows and columns we are getting. So all I need to do here, student record dot with the method is now. Then we also have dot sum. Let's print this. Let's run it. So when we run this is our outcome. If you look at this now, on the student ID, we have 3 missing. On the name, we have just one name is missing. On the sex, 3 is missing. The age, 3 is missing. The state, 4 is missing. Department, 5 is missing. The GPA is missing. Admitted at, 1 is missing. So if you look at this, since none of them is above 5, we can drop them out. So let's drop them out. Back to our code here. So what we need to do here is to drop those missing rows and columns. And for we to drop those missing rows and columns, we are going to call the method drop now. So now at this point here, we have been able to inspect our data. Then at this point, let's go ahead to start cleaning. For we to clean our data, if you look at this here, at this very line 5, we say that student record, okay, record is not, which we have already done there. So now on line 7, we said second record. That means we are trying to store the new record after we drop the missing rows and columns. We are going to store our new data frame into second record. So we call the old data frame, which is second record, and we now use the method drop now. That drop now we be able to drop every missing row and rows that we have. So to drop it there, then when we drop it there, we still have a problem. And what is the problem? The problem is the problem we are having here is there are outliers. So that because there are some age or GPA which are more than the maximum that we are supposed to get. To remove our outliers, we are going to be using our interquartile range method. So first of all, our Q1 represent our lower quartile. So we are going to say that the second record, which is the data frame without any missing rows, we call the column, which is the age, and we apply the method of the first in quartile, which is 1/4. If you remember, 1 divided by 4 we're going to give us 0.25, and the upper quartile, which is Q3, and 3 divided by 4, which is going to give us 0.75. So we apply this and we are able to get our Q1 is our upper quartile, lower quartile, and our Q3 is our upper quartile. So we're able to, now if we minus Q3 minus Q1, that will be our interquartile range, and we apply that into to get our lower bound and our upper bound. And the lower bound we say is our Q1 minus 1.5 multiplied by our interquartile range, and our upper bound is Q3 plus 1.5 multiplied by our interquartile range. And here, this part here, we now apply those lower bound and the upper bound. That means whatever what this line of code on that 19 line 19 is saying now is that we are focusing on the second record, which without the outliers, without the missing row, and we now say this second record focus on the column H, whatever that is here should be greater or equals to our lower bound, and the same second record and the same age, whatever that is here should be equal or less than our upper bound. So when we do that, we can go ahead and print the third record so that we see our outcome. We say we print our third record. So when we print our third record, our age, the age here, there is no outliers anymore. There is no missing rows anymore. There is no missing columns anymore. But the outliers here is very okay. The data here is very okay. No more outliers here. But if you look at the GPA, we still have -4, we still have 45, we still have 3,333, which is there's a problem here. So now our task here is to clean the GPA record, the GPA outliers. So now let's back to our code. So on this particular code here, so let's take away this print third record, because so the idea here is that we are going to apply our interquartile method in order to remove the outliers on the GPA. And this time now we are going to be working with the third record. So instead of using second record now, we're going to be using third record as the new data frame we are going to be working with, and we're going to store whatever we are getting into fourth record. So Q1 GPA is the container for the lower quartile for the GPA. Q3 is the container for the upper quartile GPA. So we are applying that on the third record. So that means what this is saying now, go to our data frame for the third record where the age outliers is settled. Now go to the GPA, apply our lower quartile to it, and also go there and apply our upper quartile to it. So find the interquartile range for the GPA. So when you get that, now we have our low band because we have using lower bound. So in this time around we call it low band is equals to the lower GPA minus 1.5 times IQR for the GPA, and we do the same for the upper band, and we now apply the same thing, that go to our third record. On this third record here, go to the column for the GPA and make sure that whatever figures that is there should be greater or equal to the low band and should be less than, and go to that same third record there, the GPA again, whatever figure that is here should be less than or equals to the upper band. So therefore at the end of the day we end up printing, so we print our fourth record. So let's see our outcome this time around. Discover that the GPA is clean. Our GPA is clean. No more those negative -4 or 300, whatever that is here is now clean. So now when we got a clean record here, let's look at the summary of what we are having. So see if it is still beyond what we should get. This is our summary under here. If you look at our summary, now our summary is saying that the mean age is 21 and the mean GPA is 3, which is okay. Our standard deviation is 2.3 for the age and 0.5 for the GPA. The maximum, let's look at it. Maximum age is 25. The maximum GPA is 3.99, which is very okay. And now the minimum is 17 and the minimum GPA is 2.22. So at this point we have been able to clean our data frame. So now we can make carrying out our decision, because that is the end output of every data science, to carry out a decision concerning a decision that is just concerning our data. So guys, if you enjoy this particular video and learn something from the video, please you share the video, like, and also subscribe and click that notification button for more on data science and Python and also Java classes. Thank you.